So it's now the turn of Remy to present to you the StoffenManager Nano tool. Thank you.
All right, thank you, Andrea. So we will start off with the StoffenManager Nano tool, where we will first explain what the StoffenManager Nano tool is and how it works. Afterwards, we will demonstrate the StoffenManager Nano tool by working with it with a case study. So StoffenManager Nano was developed as a control bending, risk bending tool, which was a first tier tool for the qualitative risk assessment. The tool is considered a work in progress. The tool calculates the risk by taking into account both hazard and exposure. For now, the tool only takes into account inhalation exposure to nanomaterials and only worker exposure. So here's a screenshot of the Nano module on the StoffenManager website, where you can create a free account to work with the tool yourself if you like. So StoffenManager Nano for hazard consists of 5 hazard bands from A, considered safe, to E, considered very not safe. First of all, the StoffenManager Nano distinguishes between soluble and insoluble nanomaterials, whereas a soluble nanomaterial can be modeled using the regular StoffenManager, and for insolubles, you would stick to the StoffenManager Nano tool. Next, the tool asks whether the substance consists persistent fibers via a set of questions. If it consists persistent fiber, the tool automatically allocates your hazard to the hazard band E. If it's not a persistent fiber, then your hazard classes are defined by whether your nanomaterial is mutagen and possible carcinogen. Then it would be also considered a hazard band E. If it's considered a carcinogen but not a mutagen, but also has reprotoxicity or just toxicity, it's considered hazard band D. If it's respirable toxic and a respirable irritation, it's allocated to the band C. If it's considered a harmful or an irritant, it's B, and if it has a low hazardous profile, it's considered hazard band A. If it's all these classifications are based on the toxicity data related to the nanomaterial. If the hazard data of your nanomaterial is not known, the classification will be based on the parent materials. So in this case, if the parent material are considered carcinogenic, mutagenic, reprotoxic, or sensibilization, then it's also, the nanomaterial is also considered this, and the hazard band is allocated to an E. If it's not, then the hazard band will be a D. And if the nanomaterial is included in the list of most widely used MNOs, then expert judgment on data will decide whether it's a C, D, or a E. For the exposure module of the StoffenManager Nano, the model is based on the source domains of Schneider et al., which consider 4 general applications, namely point or fugitive emission during the production phase prior to harvesting the bulk material, handling and transfer of bulk powdered nanomaterials, dispersion of solid or liquid intermediates or ready-to-use nano-containing products, and activities resulting in fracturing and abrasion of nano-containing end products. The model is based on the source receptor approach, also developed by Schneider et al., which consists of a source and a receptor, where your source consists of the emission, which is dependent on your product and your activity. The transmission, so what happens when the material is airborne, which is influenced by your local controls and your ventilation present. And the emission, which is the worker, which is influenced by whether the worker is in a personal enclosure or whether he's wearing personal protective equipment. So in general, you will have your input parameters and the multipliers, which will result to an exposure band in 4 categories. Your risk is calculated in 3 categories based on a combination of your exposure band and your hazard band, where 1 is high priority risk, 2 is medium priority risk, and 3 is low priority risk. Since StoffenManager Nano is still a work in progress, future versions we hope to upgrade to include semi-quantitative exposure values for benchmarking, include different values for different size classes to take the size of the nanomaterials more into account. We want to make the hazard assessment based more on physical chemical properties. And for these improvements, the inputs from the caLIBRAte project are definitely taken into account. So we have prepared a case study with some background information, which we will use to demonstrate the StoffenManager Nano model. In this case, it regards the production of multi-walled carbon nanotubes, which is later to be used to be put in fuel cell batteries. So we will model a synthesis process through chemical vapor condensation, and a pure product is assumed in this. Our setting is a pilot plant, so it's expected that low quantities are made for testing purposes. Therefore, we consider that the process is initiated 2 to 4 hours once in a week, where 1 operator is present. Okay, I will go to the StoffenManager. Okay, when you open the StoffenManager with your account, you can click to make a new risk assessment, which will start you off right over here to provide you input with the name of your risk assessment and your source domain. Since we have a synthesis process, we will be using this source domain, the release of primary particles during actual synthesis. The next step will be to characterize your product. So the end product would be PMFC fuel cell. You can enter the data from your supplier with the dates of your PIS and your material safety data sheets, but the model, that's more for your record keeping purpose. The model doesn't use it in its calculations, so I did not fill it in for this. The model asks here whether we know the exact concentration. Since it's a synthesis process, we estimate it to be a pure product, so we'll have 100% percentage. The products are multi-walled carbon nanotubes, so whether it's fiber-like particles, we click yes, and the diameters of the fiber or the aspect ratio is larger than 3:1. You are allowed to put in additional registration by the number of employees, your production volume, but again, these are more for your own registration purpose. The model doesn't work with these calculations, so we left them out for this demonstration. Next, we will define our activity, which was stated to be a chemical vapor condensation, but more options are present for your synthesis process in the model. The duration of the task was 2 to 4 hours a day, but you have various categories to choose from. And the frequency we chose for this pilot plant was approximately 1 day a week. It's a task, so we have to define whether the task is carried out in the breathing zone of an employee, and that would be the distance between the head and the product should be less than 1 meter. In this case, we indicated no, since during a synthesis process, it would be carried out in a reactor type enclosed machines. So therefore, it will not be carried out in the breathing zone. For the working area, since it's a pilot process, we assume that the working room is being cleaned daily and that inspections and maintenance of the machine and equipment are being done at least monthly to ensure good condition and proper functioning and performance. The working volume, the volume of the working room is estimated to be relatively small, so we take the smaller than 100 cubic meter, and we a mechanical and or natural ventilation would be present in such a room. It would not be carried out in a spraying booth. For the local control, for the local controls, we picked the control glove boxes and bags, since we are expecting these kind of controls to be taken in place when handling the reactor or a similar system, which ensures the least kind of exposure. We do not expect the worker to work in a separate enclosure. And for this case, we do not take into account personal protective equipment, because the worker is expected to be an operator, which will not be constantly in the same room of the machine and will not be wearing personal protective equipment. When all this is filled in, you can click on your last step, which would be the risk assessment, which will give you the results of your of the model run. So it has assigned us to a hazard class E. That would be because we ticked that the substance is a fiber-like substance, and our time weight exposure class is 1. So our exposure band is low. Our time weight risk score, nevertheless, is still 1. So in this case, this would be a high priority risk, of which safety measures should definitely be taken into account. And the reason for this would be that it's considered a hazardous substance.